The Sun. The reaction that powers the Sun is called fusion. Since this reaction occurs at high temperatures, it is called thermonuclear. Basically, four hydrogen nuclei fuse to form the element helium. This is done in a three-step reaction called proton-to-proton chain. The gamma rays are photons that are absorbed by the surrounding gas. This heats the gas and helps to maintain pressure. The total mass of the helium nucleus is less than the total mass of the four hydrogen nuclei, so other particles are released. These include the positron and the neutrino. The positron combines with an electron. This causes a particle annihilation which converts mass to energy. The neutrinos do not interact with other particles. They leave the Sun and carry the excess energy and momentum. The difference between the mass of the particles and the energy released is further explained by using the equation E equals mc squared. The Sun was formed when gases began to contract due to gravity. This is called the Kelvin-Helmholtz contraction. Because of the contraction, the gases began to heat. When the temperature became hot enough, fusion began and the Sun was born. Eventually, the outward pressure from fusion and the inward pressure from gravity equalize. This is called the mechanical equilibrium or hydrostatic equilibrium. The Sun keeps releasing energy, but it is constantly replacing it. This creates thermal equilibrium and a steady Sun. The mass of the Sun is 2 times 10 to the 30th kilograms. The luminosity power output is 3.9 times 10 to the 25th power watts. The Sun should keep shining for about another 5 billion years. Three types of heat transfer exist. They are conduction, convection, and radiation. Conduction occurs when heat moves from particle to particle. Convection occurs when the heat moves through liquids and gases and creates currents. Radiation diffusion occurs when the photons move from the inside of the Sun to the outside of the Sun. The Sun's atmosphere has 3 layers. The photosphere is the lowest. It gives off the visibility light. The photosphere is shallow, but the temperature is hot enough to ionize atoms. Therefore, there are plenty of ions. Neutral hydrogen atoms can absorb the free electron and become negative. The atom does not tightly hold onto the extra electron, so a photon is able to knock it out of the atom. The photon then gets absorbed by the atom. This causes the photosphere to become opaque and resemble a hot fog. The photosphere absorbs the continuous spectrum being produced by the lower layers of the Sun and produces an emission spectrum. The photosphere has molten appearance. It is made of dark-edged regions called granules. Each granule is about the size of Texas and lasts between 10 to 20 minutes before fading. The granulation is caused by the convection just below the photosphere. These are the granules. The chromosphere is in the middle. It has a reddish pink color and emits a spectrum of calcium hydrogen, and fainter than the photosphere. It can only be seen by the naked eye during a solar eclipse. The corona is the outermost layer and emits relatively dim light. Within the chromosphere are supergranules, which are bubble-like disturbances. Also, there are filaments, which are large dark areas, and spicules, which are jets of gas. These spicules move vertical through the chromosphere to the corona. The spicules are cooler gas from the lower chromosphere extending up into the hotter regions. High temperatures in the chromosphere and the corona goes against the second law of thermodynamics, which states that heat flows from high heat to low heat. Observations show that a series of looped magnetic fields called magnetic carpets extends from the photosphere. Turbulence below the surface causes these loops to move about and heat the surrounding gases, so the heat follows the flow of energy. Everything below the photosphere is the solar interior. Very little is known about this region. So we have the corona, we have the chromosphere, the photosphere, the convection zone, the flare, the prominences, which we're going to talk about. The sun vibrates. Sound waves are used to obtain information about the interior. This is called helioseismology. The sun has a magnetic field with poles. The sun exhibits different rotation, which means that different parts of the sun rotate at different rates. This is because the sun is a gas and not a solid object. A magnetic field is produced when a conductor rotates. Since the gases in the sun are ionized, they act as a conductor. Add in the rotation of the sun and magnetic field is produced. This is called the magnetic dynamo or dynamo. Irregular shaped dark areas in the photosphere are called sunspots. These dark regions were used by Galileo to show that the sun rotates. Sometimes these sunspots appear in groups called sunspot groups. Sunspot groups have polarity. As the sun rotates, the magnetic field lines from the sunspots intertwine with each other. This causes the sunspots to change polarity. Therefore, the sunspot cycle is 11 years, but the solar cycle is 22 years. A large number of sunspots can occur during a solar maximum, and a small number of sunspots can occur during a solar minimum. Huge arching columns of gas in sunspot areas are called prominences. When the sun's material is suspended above the surface, the prominence is called quiescent, which we can see right here. When the sun blasts material, the prominence is called eruptive. When the sun's material moves outward in immense arches, the prominence is called active. The most active of the prominences is called solar flares. The material can reach the corona with a velocity of 1,300 kilometers per second. You can see the solar flares right here. As well as right here too. 1,300 kilometers per second. This is a video taken by NASA on one of the solar flares that happened in 2013. There are vast amount of energy that it sent from the solar flares. The most violent eruptions are called coronal mass ejections, or CMEs. They send particles into the solar system. This is called the solar wind. The solar wind consists of charged particles. These charged particles interact with the Earth's magnetic field and produce the aurora. In the northern hemisphere, the aurora is called the aurora borealis. In the southern hemisphere, the aurora is called the aurora australis. This is another view of the sun by a different lens. When the Earth passes through the moon's shadow, a solar eclipse occurs. The moon blocks the disk of the sun because, from Earth, the diameters of the sun and the moon are equal. There are two types of solar eclipses. A total eclipse occurs when a part of the Earth passes through the darkest part of the shadow called the umbra. A partial occurs when a part of the Earth passes through the lighter part of the shadow called the penumbra. The umbra follows a path across the Earth's surface called the eclipse path. The width of the eclipse path depends upon the distance between the Earth and the Moon. The point where the Moon is the farthest from the Earth is called apogee. This creates a type of eclipse called annular. This is not considered a total eclipse because a thin line of light around the Moon can be seen.